Okay. Hi boys. This is my second time recording it, so I am praying that the audio works this time. Okay, so before we get into all of this, let's go ahead and just think about what sine of x looks like and cosine of x. If we remember, sine of x starts at the origin, so starts at 0, 0. It goes up, it comes back down, and then it meets right back at 0, where it started. And cosine starts up high, goes down, and comes back up. Both of these functions have a standard period of 2 pi. This means it takes 2 pi in order for it to start repeating. So both of these would continue on forever and ever in both directions. In this video, I'm going to go over example 7 from the beginning and example 6 then we'll end with. So example 7, I know we got most of this done during class, but I just want to give kind of another kind of re-explain it just to make sure that we all know what's going on so we're all on the same page. As I move through this video, feel free to stop whenever to take notes or whatever. Okay. So we want to write a sine and a cosine function that has its first min at 2, -7 and its first max at 7/2, 1. So I have that plotted. I know that I have to connect these points. I know they're both kind of going to be curved by the ends. So this is what I got so far. So we need to figure out what A, what B, what H, and what K are. We'll start with A and then go to K and then take a look at B. A, if we recall, is our amplitude. And our amplitude is going to be half of the full height, or the distance from the min to the max. It's going to be half of that distance. So in this case, I know that my maximum value is 1. My minimum value is -7. So I'm going to use these two numbers in order to find what that amplitude is. And some of you can probably do it in your head. If you want a little formula to follow, I would go with 1 minus a -7 over 2. Which will give me 8/2, which is 4. So my amplitude is going to be 4. Awesome. One step done. Next thing I want to think about is what that vertical shift is going to be. That is represented by that k value. Now, if my amplitude is 4, that means that my distance from the maximum to halfway down has to be 4. And the distance from the minimum halfway up, that was terrible, also has to be 4. And if that's the case, that means my midline, or that vertical shift, is going to fall right in the middle somewhere. So it's going to fall exactly 4 units away from 1 and exactly 4 units away from -7. So in this case, it will exist down at 3, -3. So my vertical shift is going to be k equals -3. Cool. So those two are pretty straightforward. Now I want to think about, okay, what about my period? Now we did talk about how that period is going to be a little funky. If I take a look at my graph, to go from a min or a max, that will take half of my period. So in this case, it's easy to see that half of my period would be the difference in those x values. So in this case, 7/2 minus 2, which is 1.5. So half of my period, it takes me 1.5 units to go half of my period, which means that my whole period, we would double that. So that would be 2 times 3/2, which is 3. Why does that help us? Well, our period is determined based on B. So if we know our period, we could find B. And if we know B, we've found the period many times. So we can set up that equation where period equals 2 pi over B. And we can use this little equation in order to figure out what B itself is. So in this case, I know that 3 equals 2 pi over B. Solving this math out, we find that our period will be 2 pi over 3. And these boxes, again, are not going to work for me. So we just found our period. We found our B value. We have our K value. And we got our amplitude. So all we need are those phase shifts. Our phase shifts are going to be different for these two graphs. For sine, it will be one thing, and for cosine, it will be something else. And that's simply because while these two graphs sort of have the same shape, they don't start in the same place. Okay? So if I have only half of a period graphed, it can be helpful to go ahead and graph the other half. And to do that, I need to figure out what some of my x values would be. So if I know that this is 3/2 or 1.5, I have to have another 1.5 over here somewhere. And yeah, you're probably doing this in your head. If I know that second half of my period has to be 3/2, that means that this here has to be 1/2. So when I get back to 1/2, or when I get to 1/2, I am at another maximum. And this looks pretty similar to one of our two functions. Which does it look close to, sine or cosine? Absolutely, that looks a lot like a cosine graph. So for our cosine, what would that shift be? How far did I move it to the left or to the right? Well, if this max should start at 0, 1, but it's now starting at 1/2, that means I shifted it to the right 1/2. So for cosine, we shifted right 1/2. And if I know that I shifted right 1/2, I can go ahead and write that cosine equation right now. So let's go ahead and do that. Y equals, my amplitude was 4. And I know I'm dealing with cosine, so I got a cosine. My period I found to be 2 pi over 3. We shifted it to the right 1/2, so that means I will have a minus 1/2. And we shifted it down 3 units, so I will have a minus 3. And look at that, we have half of this problem. Actually, we have a lot of this problem already done just by doing that work. The question becomes, what shift do I have going on for sine? There are a few different ways to think about this. Remember that sine starts at the midline and then goes up. So just based on what we have graphed now, where is a midline point? Where my function starts to go up. And you might be thinking, hey, that happens right here. So if I could find the x value that exists right there, that would tell me what my shift would be. To find that x value, well, that point will always exist halfway between kind of that 2 and that 7/2, even if it's not drawn perfectly. It will exist halfway between that. So we can do that little bit of math to figure it out. We were told earlier that that distance is 3/2. So if I want half of that, that would be 3/4. And then we just need to figure out what 3/4 plus 2 is, and that will give us that x value. Going to be 11/4. So 11/4 comma -3. So right away, we can go ahead and use that x value as our shift. So this would be a shift right 11/4. And we could go ahead and write our sine function right now. We have the same amplitude and the same b value. Now I'm shifting to the right 11/4, so I'm going to go ahead and subtract 11/4 and subtract 3 for that shift down. Now you might be thinking, but could there be another option? Could there be another answer? And that's an absolutely yes. So we could have graphed this function kind of going this way, and we could have found this next midline point down here, and that would have also given me a function that works. So if you wanted to calculate that out, you could, and this time it would just be a shift to the left, however far that is. It's another fraction. I think it might be 5/4, -5/4. But you can take a look at that if you are interested in doing so. Okay, that is one important thing to notice about these sine and cosine functions, is that there are basically an infinite number of ways to represent any of these graphs. So it's okay if you don't have the exact same answer as a friend. That doesn't necessarily mean your graphs are wrong. The way you could prove it is go ahead and graph both of your equations, see if they line up on top of each other, and see if they satisfy the given criteria. And if that happens, then you're totally fine. Okay, so that was a quick run through of example 7. I am going to go back up to example 6 and see what happens if I'm given a graph. Again, kind of similar to the last one we just did. Could I write this function using both sine and cosine? Turns out, yes, absolutely you can. Let's see how we do it. I would again go ahead and start with that amplitude, because I do find it one of the easier things to see on your graph. Remember that your amplitude is your distance from the midline to a max. So in this case, you can probably see it right away. That value would be 2. Okay. My phase shift, not my phase shift, my vertical shift. Do I have any vertical shift? Well, no, my midline would be hanging out at the x-axis, which is exactly where it is for both sine and cosine. So nothing new there. So I don't have any of those. So my k's are gone. My period. Again, this doesn't give me what my b value is explicitly. We have to find that period to then find the b value. So to do this, I would take a look at that point at 0 and say, okay, how long does it take me to go back to where I started? So I went up, I come down, and that's really convenient. This number here tells me what my period is. So in this case, my period is 3/7. And again, if we know our period, we can find that b value. So 3/7 equals 2 pi over b. This tells me that b will be 14 pi over 3. Yay. Okay, so that found me my A and my B. All I have to find are these phase shifts going on. Feel good? Hope so. Okay, to find phase shifts, it's going to be important that we have kind of some x values laid out on my graph. If I know 3/7 is all the way over here, what would my x value be right in the middle? Well, it'd be half of 3/7, which is 3/14. And my other two values, well, that first one all the way on the left would be half of 3/14. So 3/28. And this one, you could go ahead and figure out 3/28 plus 3/14, or you could go ahead and triple this value. If I triple that 3/28, I would have 9/28. So I got all those intervals. We can go ahead and figure out the phase shift for sine. Let's go ahead and try that first. Remember with sine, does it start at the middle, the top, or the bottom? It starts in the middle and it goes up. So at 3/28, I'm at the middle and I'm going up. So this is the value that I'm going to use for that phase shift. So writing my equation for sine, I know my amplitude is 2. I know my b value is 14 pi over 3. I know I got an x. I shifted to the right 3/28, so I'm going to go ahead and subtract 3/28. and I didn't go up or down at all. So my graph is good as is, or my equation is good as is. Taking a look at my phase shift for cosine. Now, cosine starts at the top and goes down. There are two different maxes on this graph. So, hey, we could start over here all the way on the left. We could start here at 3/14. Either of those would work. I kind of challenge you. What does this graph look like right away? I start down low and then I go up and then I come back down. Well, hopefully we should know at this point that cosine does that. So is there a different transformation that I could say that would make me basically flip my graph? Gotta stand on its head. Absolutely. That keyword flip should have told you what you're looking at. We could go ahead and just throw a negative sign at the very beginning of my graph of my equation, and that would tell me that I'm gonna flip my graph. So we could just go ahead and say, let's make that amplitude negative, and then I know that I'm flipping. But still have cosine, still have 14 pi over 3. And if I flip it right away, do I have any phase shifts to worry about? This point at -2 would actually come up to +2. I would come down, and then I'd go back up, more or less something like that purple one there. And hopefully you're realizing, no, you wouldn't have to shift your graph at all. And you could just leave your equation, throw an X in there, and call it a day. So kind of our key takeaways is to figure out amplitude, period, and those phase shifts and vertical shifts. Those phase shifts are probably going to be the hardest to figure out, but I'm going to be nice to you, and it will only be 1 or 2 kind of units. You won't have anything too weird for those. Okay, hopefully this video was helpful. Hopefully you understand how to do example 7. We did finish it now, and hopefully you have an idea of how to write equations giving a whole graph drawn. Cool. I will see you all later.